In the previous section, we talked about biotic factors or living factors that affect ecosystems. In this section, we'll be looking at abiotic or non-living factors that affect the ecosystem. And we're going to start with weather and climate. Now, weather and climate both involve variations in temperature, precipitation, which is rain, and other environmental factors. Now, when people talk about the weather, we're talking about day-to-day conditions of Earth's atmosphere. Sunny today, cloudy tomorrow. It's everything from day to day, where climate is an average condition over long periods of time. They talk about the rain and the temperature. If you ever watch the news to get the weather report, sometimes they'll say we're higher than average for this time of year, or we're lower than average for this time of year. They may say last year around this time we had 2 inches of rain. We're only at 1.5 inches of rain for this time of this year. So climate refers to the average conditions. Weather is day to day. Now, climate is rarely the same, even in its own region. Environmental conditions can vary over small distances, creating what is known as microclimates, micro meaning small. Microclimates are environmental conditions within a small area that differs significantly from the climate of the surrounding area. Now, climates vary all over the world. Here in December in the South, we may be able to wear a short sleeve shirt and jeans. Up north, they need heavy winter coats, pants, hat, and earmuffs. It's different all over the world. Now, our global climate is shaped by many factors. Solar energy trapped in the biosphere, and the solar energy referring to the sun. Latitude, where the land is positioned on Earth, related to north and south, and the transport of heat by winds and ocean currents. All right, solar energy and the greenhouse effect, something that a lot of people know about. Now, the main force that shapes our climate, and we're talking about Earth's climate, is solar energy that strikes Earth's surface. Solar energy referring to the sun. Now, some of that solar energy is transformed to heat and is reflected back in space, while other parts of it are absorbed. And the difference between the heat being absorbed and the energy being reflected back to space determines Earth's average temperature. Now, the difference is largely determined by 3 gases: carbon dioxide, methane, and water vapor. Now, these gases allow light in, but they trap the heat. It's similar to the way a greenhouse works, which is why they're called greenhouse gases. This describes the greenhouse effect. Now, if you've never seen a greenhouse, another example would be leaving your car out in the sun with the windows rolled up. When you get in the car, it is extremely hot. The light has been let in, but the heat has been trapped. So that's another example if you've never seen a greenhouse. Now, if greenhouse concentrations rise, the Earth will warm up because there's trapping more of that heat. If the greenhouse concentrations fall, the Earth cools off. But you got to find a nice medium, because without these greenhouse gases, the Earth would be about 30 degrees Celsius cooler than it is today, and it would be frigid temperatures all over the place. If you live in an area where they use Fahrenheit, or you're not familiar with Celsius, that comes out to about between 85, 86 degrees Fahrenheit, if my calculations are correct. All right, latitude and solar energy. Now, solar energy at the equator is intense because the sun is directly overhead. They're receiving direct sunlight. Now, this causes areas near the equator to be much warmer. Areas near the pole receive indirect sunlight, and the solar energy is spread over a much larger area due to the Earth being curved. If you think the Earth is flat, there's nothing I can do for you. I'm sorry, but you're wrong. This leads to 3 zones on Earth. The tropical zone, which is located between 23.5 degrees north and 23.5 degrees south of the equator. So when we see this 23.5 degrees north and 23.5 degrees south, we're talking about in reference to the equator. And this includes areas near the equator. We have what's called the temperate zone, which is located between 23.5 degrees north and south and 66.5 degrees north and south, moving away from the equator. And this receives much less solar energy than the tropical zone. Winter brings short days and colder weather. And then we have the polar zone, which is in the extreme north or extreme south. It's located between 66.5 degrees north and north-south and 90 degrees north-south. It also receives much less solar energy than the tropical zone, with winter bringing short days as well. So here we have this, and we're talking about the equator getting direct sunlight and areas near the pole receiving indirect sunlight. If you don't know what indirect sunlight is, of course it's not direct, but that'd be equivalent on a hot day standing in the shade. You're still receiving light, but you're receiving indirect sunlight and it's a little cooler. So when we talk about indirect sunlight, that's what we're talking about. All right, heat transport in the biosphere, and of course bio meaning life, we're talking about every living thing. Now, wind and ocean currents that transport heat and moisture are caused by unequal distribution of heat across the globe. As air is warmed, it rises because it is less dense than cold air. And warm air is less dense, and less dense things rise, more dense things sink, and it spreads out. Now, as it spreads out, it loses heat, causing it to become cooler, and it will sink. And as it warms up, it will travel over Earth's surface. Well, when we're talking about air cooling and sinking, warming, and rising, that's going to create the winds here on Earth. Now, winds generally blow from west to east over the temperate zones and east to west over the tropics and poles, and that is due to Earth's rotation. It is very similar in the ocean, except it's with water. Surface currents, however, can affect the weather and climate of nearby land masses. For example, in Florida, the ocean absorbs a lot of heat over the warm months. The heat is released throughout the winter months, keeping us a little warmer than we usually would be during the winter months. All right, and that's it for this one. If you have any questions, you can always post a comment below. We'll see you guys next time.